Hi everyone, this is Mr. Murray. We're going to build on the two-way tables we've been working on and calculate some things that are called conditional probability. So conditional probability, it's the probability of an event B occurring given that A has already occurred. And they have this special symbol here, it's this bar, and you've seen that before with domains and things. It means such that or given or having. So for example, Miss Sanfini's third period class, what's the probability that a student randomly selected will be a boy who plays soccer? So in other words, what's the probability that we have a soccer player given that it's already a boy? And it can be written like this. What's the probability of soccer given boy? So there's two probabilities in effect here. It's a conditional probability. We just don't want the probability that somebody plays soccer. It's the probability that if you picked a boy, what's the probability that that boy also plays soccer? So it's a combination of probabilities, and it's called conditional probability. So let's make a table and see if we can't calculate this. All right, first, here's the formula. So the probability of A given B can be calculated as finding the probability of A intersect B divided by the probability of B alone. Let's reverse engineer a table. Okay, so I came up with these numbers. We have Miss Sanfini's class, and let's say that she has 30 students. I'll make this line a little thinner. There we go. Okay, 30 students. Now, of those 30 students, 13 are male, 17 are female. So we have this total here, right? And the total for male will be 13. The total for female will be 17, giving us the 30 that we need. 3 males play soccer, 4 females play soccer. Okay, so 3 males, soccer players, 4 females, soccer player. Well, this total here can be 7. Now, total of males is 13, so if 3 of them play soccer, then you can just deduce that 10 do not. And if 4 females play soccer, then 13 do not. We'll total this column up this way, and we get 23. So these two-way tables are kind of cool. They have totals all over the place. The bottom right is going to always be the grand total. This is everybody, all the players involved. But then you've got these subtotals. So the number of soccer players is 7, the non-soccer players is 23. But then you can break it down in a different way. We can talk about gender. So 13 are male and 17 are female. But notice how males and females add up to 30, and soccer, non-soccer adds up to 30. That's why it's called a two-way table. The probability of choosing a soccer player having already chosen a boy is the probability of soccer intersect male. So that occurs right here. We have soccer intersect male right here. Here's soccer, and here's male. So that's the intersection, 3. So there are 3 male soccer players out of a total of 30 students. So let's write that down. So the top will be 3 out of 30. Now what's the bottom? Probability of boy or male. So the probability of male is right here. We have male is 13 out of 30. So let's write that in. Now you remember how to divide fractions. Keep, change, flip, or multiply by the reciprocal. So let's bring this up here and say multiply by 30 over 13 and check out what happens. 3 out of 13. So that is the probability of choosing a soccer player having already picked a boy. Let's get the probability in decimal format. 0.23. There's a 23% chance. So that's how we can use two-way tables to calculate conditional probability.
I could just throw a rock and then aim it at your neck so you'd get 2 stitches.
Better get down, gonna dance, good friend. Jigga chick, jabba jabba.
All I know is I know this is the bad guy, and I know this is a good one.
Ducky, ducky, turkey, turkey, duck, duck, duck. Move.
That guy bumped me.
So wait, you're saying if you don't like her, then you'll buy a girl a second-hand handbag?
I think my face is happier, Fuzzy.
I wonder, how much do I offend you?
Well, friends of mine know that I don't like you.
Oh, that's nice.
Dude, pick up that penny.
I wasn't loved as a baby.
You know, I like Horace, the little mystery pig. He's got round poops.
Funtown!
Come on, hug Daddy. I love my gopher. Hey, simmer down, yeah? Yeah.
I thought about what you said, man. I got my Legos and I'll bring them.
Oh, okay.
And then we can play all day.
Man, who took my skin cologne?
I like strong pickles, but not the funk house kind, all right? I'll toss them out.
That girl! She's so pretty! You guys don't have a problem with this?
I like this hat.
Yeah, I once got a rake, and I killed a snowman.
Villain.
It's a little more advanced than just a straight up probability of what's the chance of picking a boy out of the class. It's got two probabilities built in, and that's why it's called conditional. One probability conditioned upon another one already happening. Let's take a look at this table that's already been filled in for us. This is the Titanic disaster. And it gives a bunch of information. First class passengers, second, third, crew members. So as you can see, the cool thing about two-way tables is it totals it for all these rows. But then it also totals it for all these columns. It's a two-way table. It's very nice. Let me clear that out. Okay, so what's the probability of a passenger surviving given that they were a first-class passenger? So in other words, we can call that probability of survival given first class. And we know our formula says that that's the same as the probability of surviving and intersect first class divided by the probability of first class. So, where is the intersection of surviving and first class? Here's surviving. Here's first class. Boom, 203. So 203 divided by the total passenger list of 2,201. We're going to divide that by just the probability of first class. So the probability of first class is going to be this total down here. So that one is going to be 325 out of 2,201. So divided by 325 over 2201. Using the reciprocal, you'll notice that the 2201s will cancel, and your end result will be 203 divided by 325. That gives us a percentage of probability, of 0.625, or about 62%. Next one, what's the probability of a passenger surviving given they were third class? So that would be the probability of survival given that they were third. So for third, we'll write 3. Okay, so that's the probability of survival intersect third class divided by the probability of third class. Where is the intersection of surviving and third class? That's going to be right here. Third class, surviving. Okay, 178 out of 2201. Let's divide that by just the probability of third class, which would be 706 divided by 2201. Remember, when you multiply by the reciprocal, these 2201s will cross cancel, and you'll be left with 178 over 706. The probability in decimal format is 0.321. So who had a better chance of surviving, first or third? I'm going to say first. And the reason being, a higher probability of survival. One was 62%, the other was 32%. Now, this last one's worded a little bit differently. What's the probability of a passenger being a crew member, given that they survived? So this is going to be the probability of crew given survival. It's still the same up top. You know, it's going to be the probability of crew member intersect survivors, but then divided by probability of survivors. That's a little different than what we were doing. So let's take a look at where that is in our two-way table. Okay, crew intersect survival. So crew, survival, top line, right? 212. 212 out of 2201. Divided by probability of survival. Well, everyone who survived, right? That's 711 out of 2201. Multiply by the reciprocal, the 2201s will cancel. And you get 221 out of 711. And in decimal format, that's going to be 0.296. Sorry, it almost got cut off there. 0.296, or almost a 30% probability that it was a crew member if they had survived. Okay, two more examples. Let's do with M&Ms. You have a bag of 36 M&Ms, and there's 10 reds, 14 blues, and 12 greens. What's the probability that you pick 2 blues in a row? Okay, so it looks kind of weird, but you can think of it as probability of blue given blue. And if we want to use our formula, we can say, okay, that's the probability of blue and blue all over probability of blue. Now, the intersect feature is multiply, and we'll learn a little bit more about that in our next video tomorrow night. But what's the probability of picking the first one blue? So that would be 14 out of a total of 36. Now, to pick the next one blue, would you agree that it's really just 13 now because one blue is already in your hand or eaten, and now it's out of 35? Because there's only 35 M&Ms left, you already took a blue one out of the bag. Now let's divide that of the probability of blue. Well, just the straight up probability of picking a blue is 14 out of 36. So what happens here is kind of neat. They cancel, and the probability is just very simply 13 out of 35. And the decimal equivalent of that is 0.37. How about this guy? And it's not M&Ms, sorry. That was just a typo. You have 1,200 students, 250 seniors, 150 students take math, 40 of them are seniors taking math. What's the probability that you'll choose a student who is a senior who is taking math? So that's like saying the probability of math given that you've already chosen a senior. And you'll remember that that means it's the probability of math intersect senior, all divided by probability of senior. So they've kind of done the work for us here because the probability of math and senior is this guy. 40 students, because they're also taking math and they're seniors. So the work has been done. So that's 40 out of a total student body of 1,200. Now we divide that by just seniors. So you have 1,200 students. How many did they say were seniors? 250. Cool. So again, as usually happens, the 1,200s will disappear when you multiply by the reciprocal, and you're left with 40 out of 250. So in this conditional probability, 40 divided by 250 is 16.16, or 16%. That's the probability of picking someone who takes math having already picked a senior. So you pick a senior, what's the probability that that senior also takes math? 16%. That's called conditional probability. I hope you enjoyed this video, and we'll see you tomorrow in class. Take care.